Section 4.5 covers one of the most important techniques used to find antiderivatives, and this is called integration by substitution. It's also commonly known as doing U substitutions, and you'll see why in a moment. The goal is to run the chain rule backwards. Here's what I mean by that. We know that the derivative of sine of x cubed is equal to cosine of x cubed times the derivative of the inside, which is 3x squared. The rule that we're using here is that the derivative with respect to x of sine u is equal to cosine of u times u prime. So in this case, u is x cubed, so the derivative of sine of u is cosine of u times u prime. But if the derivative of sine of x cubed is cosine x cubed times 3x squared, then that means that the antiderivative of cosine x cubed times 3x squared is equal to sine of x cubed. So that means that the antiderivative of cosine of x cubed times 3x squared dx has got to equal sine of x cubed plus c. So when doing U substitutions, we want to know how to recognize something that looks like this as an antiderivative that looks like this. So once again, let's think about the x cubed as being our u, and then notice that if u is equal to x cubed, then du, the differential of u, is equal to 3x squared dx. So if this is u, then this is the differential of u. And then the answer, or the antiderivative, is sine of u plus c. So let's see if we can put this kind of into a more step-by-step procedure. Let me show you what it's going to look like when we find the antiderivative of cosine of x cubed times 3x squared dx. The first step is going to be to identify the u. In this case, and in general, u is usually a function which is inside another function, because that's when you apply the chain rule. And remember, we're trying to do the chain rule backwards. So the first step is to identify that we're going to use u equal to x cubed. The second step is to calculate the differential of whatever u it is that you chose. So if you choose u equals x cubed, then du is 3x squared dx. Remember, the differential is the derivative times dx. The third step is to substitute into the integral. First, I want you to substitute the differential in, and then the rest. We're going to see some problems a little bit later where it makes a difference what order you use. So first of all, since du is the same as 3x squared dx, I'm going to replace the 3x squared dx with du. So first of all, you substitute the differential, and then This x cubed, I can replace with u. So this integral, or this antiderivative, becomes the antiderivative of cosine u du. Well, that now is an easy one. Now you take the antiderivative. So the fourth step is integrate with respect to u. And then finally, you replace u with x cubed. So you substitute the x's back in. And that's the last step. So notice that the pattern is, first of all, you find your candidate for your u substitution. Usually that's going to be a function which is inside another function. Next, you calculate the differential, and then you substitute in, so instead of having an integral with x's in it, you have an integral that only has u's. So all the x's are gone, and now you have an integral with respect to u. Usually, if you're doing things correctly, then this integral is going to be simpler looking than the one that you started off with. You find the antiderivative, and then finally, you substitute your u back in for x. You replace the u's with the equivalent expressions involving x. Let's do one more. Oh, sorry. Let's postpone the examples to the next video.